We're going to talk about chapter 22 now, which is comparing two proportions. So we're going to look at doing a hypothesis test and confidence intervals for two different proportions instead of just one. Today we're going to focus mostly on the confidence intervals, and then the next video we'll talk about the hypothesis tests. Comparing two proportions. Comparisons between two percentages are much more common than questions about isolated percentages. Plus, they're more interesting. We often want to know how two groups differ, whether a treatment is better than a placebo control, or whether this year's results are better than last year's results. So we often are comparing things rather than just looking at things in an isolated situation. That means we have to have another ruler. In order to examine the difference between two proportions, we have to have another ruler. In other words, like another standard deviation or another standard unit to go by. We're still using standard deviation, but the standard deviation of the sampling distribution model for the difference between two proportions instead of just one proportion. You need to remember that we can't add standard deviations, but we can add our variances. In fact, the variance of the sum or difference of two independent random quantities is the sum of their individual variances. Basically what that means is that we just have to add the variances together and then take a square root of the whole thing. The standard deviation of the difference between two proportions. So as long as proportions observed in independent random samples are actually independent, we can add their variances. So the standard deviation of the difference between two sample proportions will be the square root, so the whole thing is inside of a square root, of P1Q1 over N1 plus P2Q2 over N2. Note the equation didn't really change except we have two, so we add them together and then take the square root of the entire thing. For standard error, it's basically the exact same thing, except instead of P and Q, it's P hat and Q hat. That's the only difference, because now we're estimating instead of knowing our population parameter. Assumptions and conditions. So whenever we do a confidence interval or a hypothesis test, this only works in specific conditions. So we need to check those. They really have not changed. So for the independence assumption, we have the randomization condition. That is the same. The data in each group should be drawn independently and at random. Then we have the 10% condition. If the data are sampled without replacement, the sample should not exceed 10% of the population. And then we finally have the independent group assumption. This is really the only new one that we're going to have to deal with. So the independent groups is basically saying that the two groups that you're comparing don't affect each other. They have to be independent from each other. For the sample size condition, each of the groups must be big enough. So the only condition we have is a success-failure condition, and you have to check it for both groups. Not just one of them, not the combination, but each group separately. The sampling distribution. We already know that for large enough samples, each of our proportions has an approximately normal sampling distribution. So all that is saying is that if we have a large enough sample, and we were to imagine all the possible different samples and plot their results, we would end up with a normal model. The same thing is true for their difference. So if you have two different samples and you subtract them and you do all the different possible combinations you could think of and plot them all on one histogram, again, you would have the normal model. So we can keep doing the same thing we've been doing. And that's a good thing. The sampling distribution continued, provided that the sampled values are independent. The samples are independent, and the sample sizes are large enough. In other words, we've checked our assumptions and conditions, and they are met. Then the sampling distribution of P hat 1 minus P hat 2 will be modeled by a normal model, where our mean is the population parameter for the first sample minus the population parameter for the second sample. And the standard deviation is, as we saw before, the square root of P1Q1 over N1 plus P2Q2 over N2. For a two proportion Z interval. So now we actually know how to do two different type of confidence intervals. We know how to do a one proportion Z interval, and now we're going to end up knowing how to do a two proportion Z interval. When the conditions are met, we are ready to find the confidence interval for the difference of two proportions. The confidence interval is P hat 1 minus P hat 2 plus or minus our critical value times the standard error of the difference in our proportions. So the standard error will be the p hat q hat over n and p hat 2 q hat 2 over n2. Again, we're using the values that we got from our sample because if we're making a confidence interval, we don't know the true population parameters. Also, the critical value depends on the particular confidence level C that you specify. So if it's 95%, you use 1.96. Those values aren't going to change. Your critical values stay the same. So looking at an example, would being part of a support group that meets regularly help people who are wearing a nicotine patch quit smoking? People are divided randomly into two groups. Group 1 meets for 6 months, and it turned out that 46 of the 143 of them quit smoking. Group 2 did not meet, and 30 of the 151 people quit smoking. Do these results suggest that support groups could be an effective way to stop smoking? The first thing we have to do with our example is check our assumptions and conditions. The first condition that we're going to have to check is our random condition. In the problem, it specifically stated the samples were taken randomly. The second condition is our 10% condition, and the first sample size is 143, plus our second sample size of 151 is going to be less than 10% of all smokers. And then for the independent groups, those attending a group will not have any effect on those. No. And then finally, the success fail. So for the first group, the number of successes is 46, which is greater than or equal to 10. And the number of failures is 97, which is also greater than or equal to 10. That's for the first group. We have to check both groups. The second group has 30 successes, which is greater than or equal to 10. And they have 121 failures, which is also greater than or equal to 10. So we've checked all four conditions. So random, it was stated that the samples were taken randomly. The 10% condition, 143 plus 151 is less than 10% of all smokers. The independent groups, those attending a group will not have any effect on those not attending the group. And then the success-fail condition. Our first group, 46 successes, 97 failures, both greater than or equal to 10. Our second group, 30 successes, 121 failures, both greater than or equal to 10. After we have checked our assumptions and conditions, we can move on to the mechanics. So in this case, we're going to say that group 1 is p hat 1, and group 2 is p hat 2. So then p hat 1 is equal to 46 out of 143, which is 0.322. And p hat 2 is equal to 30 out of 151, which is 0.199. Then we have to find the standard error. The standard error is equal to the square root of our first group plus our second group. So 0.322 times 0.678 over 143 plus 0.199 times 0.801 over 151. And that is equal to 0.051. Remember that with a confidence interval, we have to subtract our two proportions. We're looking for the difference between them. So p hat 1 minus p hat 2 is equal to 0.322 minus 0.199, which equals 0.123. So to find our confidence interval, we take the difference between our sample proportions, 0.123, plus or minus our margin of error. Now remember, the margin of error is equal to the critical value times our standard error. For 95%, our critical value is still 1.96. And then times our standard error of 0.051. And this gives us a confidence interval of 0.023 to 0.223. And that's our confidence interval. But remember, whenever we calculate a confidence interval, we have to interpret it. So to interpret our confidence interval, we can give a conclusion by saying we are 95% confident that based on these samples, the proportion of people who quit smoking while attending a support group is 2.33% to 22.9% greater than those who quit smoking without attending a support group. That is it for tonight. I hope everybody has a great night, and I will see you guys tomorrow.